Throughout history, all major inventions that were mass adopted were first adopted by large enterprise. From the steam engine to the telegraph to even the internet, this pattern has remained true throughout time. Hedera Hashgraph, or HBAR, follows this same pattern. So in this video, I'll take you through the HBAR protocol. We'll look at its technical features at a high level, we'll understand what it can do, and we'll also understand what are its unique competitive advantages against other blockchains. This will be the first video of an ongoing HBAR series on this channel, so if you want to learn more about HBAR, hit the like and subscribe button. It really helps the channel out a lot. Thanks, and let's jump right in. HBAR is built with something called the Hashgraph distributed consensus algorithm. This consensus algorithm is capable of hundreds of thousands of transactions per second in a single shard. This algorithm is unique to others as it is fundamentally different to a blockchain. In fact, it is not a blockchain, it is something called a directed acyclic graph. This architecture gives it incredible scalability in a way that has effectively solved the blockchain trilemma. Because you see, in a blockchain, blocks of transactions form a single long chain. This takes time to do, and it is why you basically have to wait a couple minutes for something called finality on Ethereum. It's basically when the longest chain has been confirmed. This process is actually made artificially slower in order to reduce the chances of two forking chains by using mechanisms like proof of work and proof of stake, putting a limit on scalability. And it is why you see all these layer 2 scaling solutions in the market today. But the problem with layer 2 scaling solutions is fragmentation. It splits up the user base and reduces network effects in those networks. With Hashgraph, every transaction container is incorporated into the network state. None are discarded. However, all are woven together into a single network state, making it fundamentally more efficient and faster than blockchain. In fact, its speed is only limited by the internet connection itself, and even a home broadband connection is enough to enable Visa-level transaction volume. This means that HBAR is inexpensive, costing less than a cent for any transfer sum of HBAR, and of course it is fast, capable of speeds of over 100,000 transactions per second. Now this is achieved through something called the mirror network. I won't go into too much detail here, but just know that provisions have been made on HBAR to enable it high scalability. Furthermore, a study was done by University College of London showing that it has one of the lowest energy consumptions of any network. We can see on this graph here, these are a bunch of L1s with their energy consumption plotted on a graph, and HBAR here is sort of this purplish color, and oh, there's a lot of colors here. Obviously, yeah, okay, it's the one at the bottom here, which is the lowest out of any network. Now moving on to security, HBAR achieves its security via a number of ways. Firstly, it uses asynchronous Byzantine fault tolerance. I'll just say ABFT for ease from now on. This advanced model is used as part of consensus alongside proof of stake, although it is not a unique differentiator as many of the top blockchains also use ABFT. Now ABFT has mathematically provable the highest security standards compared to all other models. It is more resistant to botnets, DDoS attacks, malicious firewalls, and functions even in unpredictable network conditions. Now, although ABFT is not a unique differentiator for HBAR in this regard, the way HBAR treats transactions and the use of fairness involved in their model is quite unique. In HBAR, all nodes are treated equally, so instead of giving more power to a node which has more stake in the network, all nodes are treated equally, and transaction speed cannot be increased by paying more for a given transaction. This differs from Ethereum, XRP, and Cardano, for example, where paying for transactions creates a number of problems such as front running. Furthermore, HBAR's consensus is not leader driven. This actually differs to a number of blockchains. The benefit of not being leader driven is that if the leader for whatever reason is compromised or malicious, they could negatively influence consensus in their own favor. Next, let's look at the governance and stability on HBAR. So governance on a blockchain is just simply how stakeholders, so Token holders, you, me, nodes, dApp developers make decisions about the operation and future direction of the network. So if you didn't know, many networks actually have ways for you to propose certain improvement proposals, and other users or stakeholders on the network can discuss and vote on the outcome of that proposal. Things like upgrades to the network are proposed, debated on, and voted on. Now, one thing for HBAR here that really stands out is that it is governed by some of the largest enterprise in the world. I have yet to come across another blockchain with this caliber of governance members. So as you can see here, this is the governing council of 39 of the largest global enterprises. These are organizations like Google, IBM, Tata, Mondelez, and more. What this means is that these world-class organizations actively debate and drive the future development of HBAR. This is important to know because these organizations are interested and invested in the success and growth of HBAR. Another notable thing for HBAR is that it is highly resistant to forks. So forking simply refers to when the network splits, and this can happen if all members agree to it. Hard forks is literally when a network splits into two separate versions, which is basically what happened in the past with Bitcoin and Bitcoin Cash, or Ethereum and Ethereum Classic. Forking has arguably damaged the network effects of these networks. So ideally, we want to invest in something that cannot be forked, but unfortunately, forking is not 100% avoidable, but a network can be highly resistant to forks. With HBAR, it is more difficult to fork simply because of how it is architecturally set up. I won't go into too much detail here, but basically the original version governed will always be chosen. And this is further ensured via defensive patents to help prevent forks. Now, there are other networks which are also highly resistant to forks, so it is not unique to HBAR, but it is nice to see that HBAR has made explicitly clear how they aim to prevent forks, with being intentional about their architecture and also the legal side to it with the patents and stuff like that. In terms of stability, now the network remains stable and secure so long as malicious actors control less than 1/3 of the total stake on the network. Now, this is not unique to HBAR. 1/3 is pretty much the standard number when it comes to Byzantine fault tolerant models. So this is pretty common in that regard. But the bottom line here with stability on HBAR is that the fairness via timestamping is a unique differentiator, as many networks use a leader-driven model instead. Now, next, let's look at the privacy and regulatory compliance on HBAR. Now, for a network to be mass adopted by large enterprise, it must have some capability to control regulatory compliance. It's just a must for large enterprise. With HBAR, permission controls are actually baked into the protocol itself, allowing different accounts to have different permissions. This is pretty different to many blockchains where the permission controls are on the application layer, whereas within HBAR, it is baked into the protocol itself. So for example, one thing that is a big impediment to user experience is account recovery. As you know, if you lose your keys, you can't recover them. It's basically your responsibility. But with this capability here, HBAR developers can put in some feature to recover your keys for you. And with this, you can obviously see that enterprise can comply with certain regulations like account recovery and stuff like that. Data is also self-sovereign on Hedera, meaning that when any data is published, the publisher can define permissions on which keys have permission to delete or modify the data. This allows developers to build applications which can comply with things like GDPR, essentially allowing its users to maintain full control of their data. This is pretty different to many networks where you're basically not allowed to change data on a blockchain. But with this provision here, it seems like certain keys have ability to actually modify their data. Now, in terms of privacy, data is recorded as a hash on the blockchain. I won't go into too much detail into how this is actually done, but basically it allows you to retain the privacy of the actual underlying data. And this data could be anything from identity, healthcare records, supply chain data, IoT, device identities. Know Your Customer is also baked into the protocol. Users can decide to either attach their identity to their account on the blockchain or remain pseudonymous. So when using the account, a counterparty can do the appropriate KYC checks to accept the transaction. This gives control to enterprise to be able to fulfill their consumer protection and regulatory compliance obligations. So again, here, this is pretty unique that it is actually baked into the protocol. Now, regulatory compliance is something that frequently goes overlooked in many networks, and it is nice to see that HBAR has explicit provisions for it here. It is definitely a unique differentiator for HBAR. For certain use cases like supply chain, digital identity, healthcare, things involving sensitive data, large enterprise will not feasibly adopt a network which does not have this capability thought out. With HBAR, it is unique in that it is built into the actual network protocol, differentiating it from other protocols, making it more attractive to large enterprise. Okay, so now we've gone through the technical fundamentals of HBAR protocol. Let's take a look at what makes the service layer unique on HBAR. So in the service layer here, we can see there are 4 key components. First is the actual cryptocurrency HBAR. HBAR here is used to transfer value between accounts, such as for payment applications, data purchases, paying for transactions, staking, and paying for nodes on the network. This is pretty common among most blockchains, and we can see here that HBAR is used as both as a cryptocurrency and as a utility token. Secondly, there is file storage. Users can record information on chain whilst only a hash of the information is visible. This is achieved via Merkle trees. Again, I won't go into detail about what these are or how it's done, but essentially it's an efficient way of storing files without actually uploading the data of the file to the blockchain. This keeps the blockchain lightweight, which is better for scalability. This is pretty unique in that most networks do not offer native file storage. Most blockchains rely on other networks such as IPFS to carry out file storage. The fact that HBAR has built-in file storage reduces complexity. Next, we have smart contracts. Smart contracts allow developers to build trustless applications and business logic. Smart contracts on HBAR are currently written in any programming language that can be compiled to EVM bytecode. Now, EVM is basically what Ethereum developers use. Now, this is important to note, as whether we like it or not, Solidity is the most used language among crypto developers at the moment. This means that HBAR-based companies looking to hire developers to build using HBAR will have a relatively easier time hiring developers, which is conducive to adoption overall. And of course, with smart contracts, you can also create your own custom tokens on HBAR, fungible and non-fungible, which inherit all the benefits of the Hashgraph consensus algorithm. Now, this is not unique, but it is nice to see that these large enterprises can essentially go off and create their own tokens. And lastly, there is the HBAR consensus service. Now, this is where it gets pretty interesting, actually. The consensus service allows users, even users who are not on HBAR, to submit transactions to HBAR for transaction ordering and transparency, a kind of consensus as a service solution. I can see this image here with a Hyperledger Fabric integration. I won't go into detail on this in this video. I'll do it in another video, but yes, they're working with IBM and Hyperledger Fabric. But why would large enterprise need transaction ordering and consensus? Well, transaction ordering and consensus and transparency is actually required by many large enterprise. And we can see here, Siemens, they require consensus on large streams of data from their IoT devices. Goldman Sachs, they analyze large streams of market data, crucial for real-time financial data analysis and trading applications. And then we have Alibaba here. They optimize their inventory management in real time. Now, these organizations already use centralized solutions like Apache Kafka and Apache Flink. These already work well. However, issues occur when enterprise need to handle data in untrusted environments. Untrusted environments mean they handle data with organizations outside of their own. So for example, material quality assurance, visibility across multiple manufacturers, supply chains, and retailers, cross-border trade, finance across multiple banks, exporters, and insurers, or supply chain visibility across multiple manufacturers, supply chains, and retailers. This means that these enterprises that require consensus and transparency in these untrusted environments can submit their transactions to HBAR, benefiting from fast, decentralized consensus as a service without actually needing to build their own system. Now, in this regard here, HBAR is pretty unique. Whilst other networks are capable of this, it seems that HBAR is really making this their core offering. And as we can see from the regulatory compliance and the fairness and the caliber of governance members, it seems like they're really focusing on that large enterprise market. Finally, to end this video, we'll look at interoperability. If you don't know what interoperability is, it is basically the ability for different systems to exchange information seamlessly with each other. It's just really important, and you can learn more about it in my other video here. I'll just link it up here. So HBAR currently has this application called Hashport. It is a multi-chain bridge allowing the transfer of tokens between two networks. So for example, Ethereum and HBAR. However, there are of course other networks available on here. But to understand where Hashport sits in terms of interoperability, you also need to understand that there are 5 different types of interoperability. I cover it in my interoperability video, and without going over the whole thing again, basically Hashport seems to mainly provide only one type of interoperability, which is the ability to transfer assets across 2 networks. Now, this is what Hashport can provide so far, but indirectly, the Hedera consensus service may also provide more. But from what I can see, this is the current functionality. The Hedera consensus service itself could also fulfill interoperability by providing state to applications, but we'll table this discussion for now. If we compare it to other interoperability solutions out there, there are, of course, more advanced solutions such as Quant Networks Overledger, which is built for all 5 types of interoperability. But this makes sense as HBAR is not solely focusing on interoperability. They aren't trying to be an interoperability protocol. Hashport is simply a public good and it's there if you want it kind of thing. I mainly see Hashport as being a life raft for Ethereum developers. So I would see Hashport mainly being a channel for adoption for HBAR. Okay, so that's it, guys. I'll just summarize the unique differentiators of HBAR. So we know that HBAR is not a blockchain. It is something called a directed acyclic graph. Because of how it is architecturally set up, it is more scalable compared to blockchains. Its fees are low and it has the lowest consumption compared to any other top L1 network. In terms of security, it is unique in that it uses timestamping. This makes it more resistant to malicious actors and reduces the effects of malicious actors. With governance, its unique differentiator is definitely how it is being governed by 39 of some of the largest enterprises in the world. This is quite unique. I've not seen this in any other blockchain. In terms of privacy and regulatory compliance, we can see that HBAR has made a lot of provisions for this. It is basically being set up as the L1 network for large enterprise. And finally, we have the HBAR consensus service. This is definitely unique. This is a consensus as a service type of solution, and it is targeting large enterprise which need consensus and transparency in untrusted environments. Because of all the previous provisions and how it's architecturally set up, you can see that it is focusing on the large enterprise market for this. Okay, so that's it, guys. Thanks for watching the video. Hope you enjoyed the video. If you have any feedback or comments, just leave it in the comment section below. I read and go through all comments. In the next video, we'll look at the team of HBAR. Thank you very much, and I'll see you next time.